Welcome to the instructional guide for DTS 3D training. This software is now in its 2.0 version. Let's initiate by uploading the patient details. Upload the intraoral scans for both the upper and lower jaws. The intraoral scans can be uploaded in STL, PLY, or OBJ formats. Upon uploading the scan, the AI seamlessly identifies both the teeth and the gingiva automatically. All parts of the scan outside the highlighted green area will be trimmed. Zooming in and out of the scan can be accomplished using the center wheel of the mouse. To scroll the scan in any direction, press the center wheel of the mouse and move it in the desired direction. Ensure the scan is free of any holes or gaps. You can adjust the size of the highlighted area using the expand slider. Be certain to incorporate a portion of the gingiva within the selection. You can add or remove from the selection using the respective tools. The brush size of the Add, Remove tools can be adjusted using the sliders. The Select All tool chooses the complete scan, while the Clear All tool removes the entire selection. After finalizing the selection, the AI will proceed to trim and refine the scan boundaries for a smoother outcome. The duration of this process may vary, typically taking a few seconds depending on the speed of your system. Similarly, let's proceed with uploading the lower jaw scan. As evident, there's an isolated selected part distal to the molar. Simply utilize the Remove tool to deselect it. We can add color to the scans if needed. Let's proceed to upload the patient photos saved in the DTS Pro, specifically in the 2D project file. It's important to note that direct uploading of patient images into the 3D software is not possible. First, upload them in the DTS Pro 2D software, save the project file, and then import it into the 3D program. Click the Next button to advance to the intraoral scan alignment screen. The AI has automatically identified the landmarks. Yellow points mark the molars. Red points should align with the canine cusp tips. And the blue point denotes the midline. Left-click on the points to adjust and refine their positions as needed. If automatic detection hasn't occurred, refer to the help guide on the right and manually mark the points by left-clicking. Ensure to follow the sequence indicated in the help tip while marking the points. After marking the alignment points, click the Done button. This will lead us to the second alignment screen, where we can enhance the position of the occlusal plane using the 3D control points. Ensure a close match to the midline. Position the yellow dotted curve slightly labial to or at least on the incisal edges. Once the alignment is finished, click the Next button to proceed to the mapping screen. Here, overlay the intraoral scan with the photo by following the help tip. Left-click to mark 3 common points on the photograph and 3 corresponding points on the scan, observing the color coding. The first and third points can be placed on the canine or premolar cusp tips, while the yellow second point should always be marked close to the midline. If needed, press Reset to delete marked points and start again. After the points are marked, press the Check Fit button. To achieve the best possible fit, adjust the position of the intraoral scan as follows, and confirm the fit using the transparency sliders. To rotate, left-click outside the scan area. To resize the scan, left-click and move the control points. To move the scan, left-click within the scan and move the mouse. Up, down, or right, left. Strive to achieve an optimal fit between the image and the scan, keeping in mind that the image is 2D while the scan is in 3D. It might not be possible to achieve a 100% overlap, but aim for the closest match, especially in the anterior segment, for effective 3D smile visualization. Proceed to the design screen by clicking the Next button. This is the split screen view. Here we can see the scan in different orientations for easier designing. These are static views which can be zoomed in and out and flipped. Using the Show Hide button, we can select or deselect the required objects. The transparency can be adjusted using the slider. Press the Show a Hide button again to close the tab. We can navigate between the split screen and the dynamic screen view. Open the Teeth Library tab by clicking on the Teeth Library button. You can opt for either the FDI or Universal Nomenclature systems. DTS 3D offers a range of natural teeth libraries. Select the desired tooth number in the tab. It will turn green, indicating the addition of a shell. Both upper and lower shells can be added. To remove a shell, simply click on the green highlighted tooth in the tab. Edit individual shells, or the entire group by selecting all shells with Ctrl-A, or right-clicking and choosing the Select All option from the drop-down menu. Use the control points to rotate, move, stretch, or scale the shells collectively. The 2D smile templates designed in DTS Pro serve as a reference for accurately positioning dental shells. Select an individual shell by pressing Shift key and left-clicking on the shell. Or right-click on the shell and select from the drop-down menu. Any modification made to the shell in one view will change its position across all views. The split screen view makes the design process simplified as the position of the shells can be assessed in all planes of space. The symmetry function, accessible through right-clicking, induces identical movements of selected teeth on both sides. To turn off the symmetry function, right-click and deselect the symmetry option. The mirror function, available through right-clicking, allows the mirroring of teeth on one side. Both the symmetry and mirror functions can be used for only one tooth at a time. Select multiple shells by holding the Shift key and left-clicking on the desired shells. Add color to the scan or shells through the Color tab. Press Reset button to reset the color. We can select teeth from any of the available tooth libraries. We can also add different teeth from different libraries. When we add a new tooth from another library, it gets added in the same position as the earlier corresponding tooth. When you remove a tooth shell by deselecting it, and again add the tooth, its position is reset to the original. Interpreting the color coding of shells. The total number of highlighted teeth represents the number of added shells. If the shells turn green upon clicking on a library, it signifies that those specific shells belong to the selected library. Meanwhile, the remaining shells are orange, indicating they belong to a different library, which is highlighted in orange. Let us switch to the dynamic screen. Hold the Shift key and left-click to select a shell. The square-shaped controls proportionately scale the shells. Left-clicking on the long arrows, move the shell in the direction of the arrow. Clicking on the short arrows stretches the shell in the desired direction. Left-clicking on the curves rotates the shell. We can also left-click and move the selected shells to do a free hand placement. Conclude the design process to minimize the need for further refinement in the next steps. Verify the thickness of the shells by increasing transparency. Return to the static screen view to review the design against the patient photograph. Once the design is finalized, click the Next button to proceed to the Sculpt screen. This will also save the designs. Here, you can add, remove, move, or smoothen textures. For mockups or temporaries, ensure that the entire labial and buccal surfaces of the teeth are covered with the shell. In areas where the original tooth structure is seen through, we can either add material using the Add tool or move using the Move tool. To select a tooth for sculpting, press Shift key and left-click on the shell, or right-click over it. The selected tooth shell becomes highlighted. When using the Add tool, set the intensity to a minimum, and ensure a larger selection brush size so that the addition does not happen only at a small area and cause distorted shape. Keep the mouse left-click pressed and move the mouse in the desired direction. If there is sufficient thickness of the shell material, Move tool can be used for the desired effect. Left-click and drag to move. Remove tool can be used to remove any additional material, particularly from the palatal or lingual surface. Keep the mouse left-click pressed to remove material. Remove tool can also be used to eliminate any occlusal interferences using the opposing jaw as a guide. Smooth tool smoothens the shell textures. We can also refine the tooth shape using the Move tool. Sculpting changes can be carried out not only on the shells, but also on the original scan to simulate any clinical reduction. Although this step should be exercised with caution, otherwise it may affect the fit of the shells. Move tool can also be used to adjust the thickness or emergence of the shells. As a general rule, limit the use of sculpting tools to a minimum, reserving major alterations for the design screen. Proceed to the Model Builder screen by clicking Next. Here, you can choose to process the model as a solid or hollow model. Adjust the base height as needed. Opting for a hollow model can save resin during the 3D printing process. Additionally, you can add drain holes. Clicking on the Build button initiates the AI engine to create a single object by merging the original scan with the teeth shells. This process takes a few seconds, depending on your system's speed. After adding the base, you can include text on the model and proceed to export it. Let us now add a base to the opposing jaw. When making the model hollow, we can adjust the wall thickness as required. The models are now ready to be exported. Press the Next button. On the Export tab, you have several options for exporting. 1. Model Builder Maxilla or Mandible option exports the base added model. You can export just the shells, or export the scan and shells together as two distinct 3D objects, which are not merged without the base. Before exporting, the project is saved as a DTS 3D project file.